Hello and welcome to Amjadacademy in a continuation with our reagent series. Today I am going to talk on next example based on pyridinium chlorochromate, that is your PCC. So I have an example with me. This example I have taken it from the book of Karotha. So we are going to write its mechanism, what it will give us on a reaction with 1.5 equivalent of pyridinium chlorochromate in a solvent of dichloromethane CH2Cl2. What will be the product? We will see it with the mechanism. So let me write the mechanism here. Mechanism. Let me write it again. Tertiary butyl dimethyl selenium ion oxygen, then CH2, then our methyl group, then we have our alkene here, then I have this methyl here, and then OH. Now for the sake of understanding the mechanism, I am not showing any stereochemistry, and stereochemistry is not expected in this question. So what expected is the conversion of this alcohol into aldehyde by using PCC. This particular session is expected. Stereochemistry is not expected in this question. So don't worry about the stereochemistry, just go on writing its mechanism. Just be with me. Now look at here. I have the structure of our PCC, C double chromium double bond O, single bond O negative, P, Y, H positive, and then Cl. Look at here, this is structure of PCC. Now oxygen is having a lone pair, it will attack on this chromium. This oxygen chromium double bond will convert into a single bond. Let me write it. Will convert into a single bond, and what we'll get, I will write it after the arrow. Tertiary butyl group, then our dimethyl group, then selenium ion, and then oxygen, and then we have CH2. Here we have methyl group. Here we have alkene, our alkene. Here we have our methyl. Here oxygen, its hydrogen, and it is getting attached with the chromium. Single bond O negative, double bond O, single bond O negative, which is attached to P, Y, H positive, that is pyridinium ion, and here we have our chlorine. Look at, everything is same. Now this oxygen is trivalent, hence it is positive in charge. To neutralize it, this oxygen negative will abstract this hydrogen, and this oxygen hydrogen bond electron will turn towards oxygen to make it stable. And what we'll get, I will write it down. Let's see here. We have our tertiary butyl dimethyl selenium oxide and our CH2 group, and then our methyl group. Then here we have our alkene structure of alkene, and then our methyl here, and what remains here, our oxygen and chromium, single bond OH, double bond O, single bond O negative, P, Y, H positive, and chlorine. Now as you can see, now we are going to make chromate star. This oxygen, it has electron here. This electron will turn towards carbon oxygen double bond, and this chlorine, it is the best leaving group. It will leave from this structure, and will get what I will get. I will get here tertiary butyl dimethyl selenium oxide, then CH2, then methyl group, and then I have methyl group here, then I have oxygen here, it is attached with the chromium, and then we have OH, we have double bond O and double bond O, and here we have our alkene. So what is this, my dear brother and sister? It is a chromate star. Chromate chromate ester, chromate ester, chromate ester, chromate ester, chromate ester. So did you got this? Okay. Now what will be the next step? I will write next step above it, and I will rub this first. I will rub this first. Now what will be the next step, my dear brother and sister? As this chlorine, this free chloride ion which get removed in the last step, it is still present in the solution as a chloride minus ion, and I am going to write that. Look at here, this chloride, I am writing it here as a Cl minus. This free chloride ion will come again in the next step. Now look at here, this carbon, it has a hydrogen here. Okay, now in the next step, this chloride, free chloride ion will come and abstract this hydrogen, and this hydrogen carbon bond electron will turn towards carbon oxygen double bond, and this oxygen chromium bond electron will turn towards chromium, and this double bond will convert into a single bond. This is not our part is here. So look at here, let me write the structure again: tertiary butyl dimethyl selenium oxide CH2, and then methyl group here, then alkene here, and then I have methyl here, methyl and double bond O. As you can see, this carbon hydrogen bond electron gets converted into carbon oxygen double bond, and remaining structure will be as it is. What I have as a byproduct is chromium double bond O negative and this HCl. So our main target is to convert primary alcohol into secondary alcohol into ketone. So this was the example given in the book of Carruthers, and I have tried it to give its mechanism. If you like it, like my video, do subscribe to my channel, and don't forget to hit the bell icon to get the notification for the new video. Till then, keep supporting, keep watching. Thank you for coming on Amjad Academy.